Welcome to Ms. Zampano's Flipped Classroom. You're watching video 1.5. This is going to be on order of operations review. And let's take a look at our pre-arranged note sheet. Again, we're working on Chapter 1, Pre-Algebra Review. Please write your name at the top. Our section title again is 1.5 Order of Operations Review. And we're going to be working on pages in Out of Pizzazz, pages 20 and 21 for this situation. And also please add the date right there. Our first vocabulary word is operations. This is a math process such as add, subtract, multiply, divide, square, square root, etc. Our next vocabulary word is a grouping symbol, since we're going to be using GEMDAS instead of PEMDAS. So G is indicating the grouping symbol. These are symbols used to break the order of operations. These symbols include parentheses, brackets, squiggly brackets, absolute value signs. And the last one I want to make sure we all are aware is the absolute value signs. They are the straight up and down straight lines. Absolute value is a vocabulary word, is a grouping symbol that once evaluated turns the result positive if it's not already positive. It does not take the opposite. So for example, if I have the absolute value of -3, it does give me a result of a +3. But if I take the absolute value of a +3, it keeps as a +3. Let's go ahead and take a look at some of the key concepts on how to identify the order of operations, on how to compute. And again, we're taking a look at GEMDAS. You're probably familiar with PEMDAS, where we start with P for parentheses. In this case, we're going to incorporate all types of grouping symbols, so we're going to use the G instead. So the G represents grouping symbols, the E exponents, the M and the D for multiplication and division, respectively, and the A and the S for addition and subtraction. Let's go ahead and take a look at what this order of operations looks like. So, the first step is to compute anything inside the grouping symbols. These again break the natural order. Our first step when we take a look at grouping symbols is to look at what else is inside the grouping symbols. If there are exponents, those need to go first, and then if there's multiplication or division, that comes next, and then we go ahead and do addition or subtraction, all depending upon what's inside that grouping symbol. From there, we look back now that we've simplified the grouping symbol and move ahead. So, step one is sort of like, hey, look at me, I need you to pay attention. So these grouping symbols are a huge part of this order of operations. Our second step is to compute the exponents. So once we've taken care of everything that's inside the grouping symbols and simplified that, we're going to go ahead and take care of the exponents. And then we're going to multiply or divide on step 3 by moving from the left to the right. Step 4, once we've taken care of now our exponents and our multiplication and division, we're going to move from left to right and take care of our addition and subtraction, whichever comes first from that left to the right. So these little stars I have organized right here is when more than one operation appears on step 3 or 4, we're always going to be moving from the left to the right side. So think about reading. When you read from the left to the right, and that's how you know which direction to work with first. This could mean that you might be dividing before you multiply, or subtracting before you add. So with that in mind, let's take a look at a couple of examples. This case, we have multiple examples that you will be seeing done and guided, and we have 3 examples that you will be doing on your own as a try on your own. Again, those attempts of those that you try on your own, you get credit for whether or not they are accurate, and we go over them in class to work on building that accuracy and making sure your notes are correct. So our first example is 45 divided by 5 plus 3 times the quantity of 9 minus 2 squared minus 10. So when I take a look at this, I'm going to want to write down a 1 next to this example, and then go ahead and indicate a couple of pieces. Our first thing is the grouping symbol, so I'm going to organize that. I have 9 minus 2 squared, and within that grouping symbol, the exponent needs to happen first, so I'm going to write down 45 divided by 5 plus 3 times the quantity of 9 minus 4 minus 10. This is because the 2 squared is the same thing as 4. And now we're going to go ahead and simplify the subtraction inside that grouping symbol and have 45 divided by 5 plus 3 times the quantity of 5. Subtract 10. So now we're going to go ahead and multiply or divide from left to right. The division happens first, so we'll end up with 9 plus 3 times 5, which is 15, minus 10. Now again, working from left to right, I'm going to add 9 plus 15, get 24 minus 10, and then go ahead from here and just add the 24 minus 10 to get a 14. Whoops. Let's slow down and take a look at our next example. So I'm going to go backwards. And our example that I want to do first of all is I want to indicate that this is our second example that we're reviewing, and it is 6 times the quantity of negative 19 plus 8 minus 40 divided by 2. So the first thing that we're going to do is take a look at that grouping symbol, so negative 19 plus 8, and be able to simplify that to say 6 times negative 11 minus 40 divided by 2. Now that we've taken care of the grouping symbols, there are no exponents in this situation. We're going to take care of the multiplication since that happens to occur first, so that's this piece. And then also we're going to take care of the division next. So our next piece is going to look like negative 66 minus 20. When I put those together, I'm adding the opposites. And so I have negative 66 plus a negative 20, then resulting in a negative 86. So let's take a look at some more examples of what this might look like and how to look at this gem DOS with these grouping symbols. So on the back side of your note sheet, you should take a look at the vocabulary piece, and we're going to take a look at some mental math. This is computation or computing without a calculator. And here we want to break problems into easier parts, so we would write them separately. Another thing to think about when we talk about mental math is rounding to get an estimate of an answer. So for example, earlier in the year we talked about how you can mentally compute 8 times, hold on one moment. So in order to organize this example a little bit further, earlier in the year we had talked about 5 times 18 and how to mentally compute that. And we discussed a number of different ways that people in the Stanford video had done that. So that could look like 5 times 10 plus 8. That could look like 5 times 2 times 9. That could look like 5 times 20 minus 2. And being able to distribute 5 times 20 minus 5 times 2 and be able to get on all of these answers 90. So different ways of going about computing how this makes the most sense to different people and looking at what that looks like. That's all about how mental math is making things easier for your brain to process by breaking them into smaller pieces, and also an estimate of what those numbers can be. That's what we talk about when we are discussing number flexibility. So let's go ahead and use kind of this idea of mental math in our order of operations to help us out. Another thing just to be aware of as we go in through order of operations, we're going to take a look at some fractions. So knowing that a fraction bar is the same thing as a division symbol. So here we're looking down at the key concepts now. And with the fraction bar being a division symbol, anytime we take a look at that, we'll be using the order of operations in conjunction with division. And knowing that there is an invisible grouping symbol, again it's invisible, that is around the numerator. So the numerator is the expression that is above the bar, that fraction bar, and anytime we have something in that numerator that might have additional operations, it's as if there are parentheses around those. So let's take a look at some examples to work with. And our first example that we're going to take a look at is negative 23 plus, negative 23 plus the quantity of 1 minus 4 raised to the power of 3, all divided by 25. Now this tells me that my numerator has invisible parentheses around it as well. So since there's already parentheses, it's almost as if we're going to add brackets to try and indicate a difference of which grouping symbols. And we always want to work from the inside out. So if I kind of envision some brackets out here, I'm going to work to start with at the 1 minus 4 and then go ahead and work from there. So this looks like negative 23 plus negative 3 raised to the power of 3, all divided by 25. And negative 3 raised to the power of 3 can be expanded out to look like negative 3 times negative 3 times negative 3, which is 9 times negative 3, which is negative 27. So I can plug in negative 27 where I saw that negative 3 to the power of 3 and get negative 23 plus negative 27 over 25. Now I can simplify my numerator. I still need to work on that numerator because it is part of that invisible grouping symbol. And I'm going to receive a negative 50 divided by 25. That's going to give me an answer of negative 2. This was our third example, so please put a 3 next to it. And we're going to go ahead and take a look at 4 over here. So our fourth example says 5 plus negative 1 to the power of 3 times 9 divided by 2. This is one fraction that's being added to another fraction that says 360 divided by 36. So we're going to kind of indicate that these are happening first, and then also the idea that we have two fractions being added together. So let's take a look at this, and we're going to get 5 plus negative 1 times 9 divided by 2. Whoops, that came really fast, so I'm going to back that up just a hair. And if we take a look at 5 times negative 1 times 5 plus negative 1 times 9 divided by 2 plus 360 divided by 36. What I did there is I took negative 1 to the power of 3 and I expanded it out, multiplying negative 1 3 times, and I get actually the answer of negative 1. So I can simplify that, and I did in this step. I'm now going to continue trying to simplify the numerator, which is right here, and indicating I'm going to multiply first, so negative 1 times 9. So my next thing will be 5 plus negative 9 divided by 2 plus 10, since I have 360 divided by 36. Still, I can simplify that numerator further to get 5 plus the negative 9, all divided by 2, plus 10, giving me a negative 4 plus 10, negative 4 divided by 2 plus 10 rather. And negative 4 divided by 2 can simplify to negative 2 plus 10, giving me a positive 8 as my result. Let's take a look at a few more examples, and then we'll have you try some on your own. So our next example is example number 5, right down here. And it has less parts to it. So 16 minus 5 times 2 divided by 4. And here we're going to write this answer as a fraction. So here I'm going to organize within the grouping symbols right here. And I'm going to have to multiply before I do that subtraction. So I'll end up with 16 minus 10 the quantity of, all divided by 4. And I'm going to simplify to get 6 divided by 4, which can look like 6 over 4, which can also be reduced to 3 over 2, which is the same thing if I use as an improper fraction currently and change it to a mixed number, and I'd get 1.5. The sixth example we're going to take a look at is also a little less complicated than our 3 and 4 examples up above, and says 19 minus 3 times the quantity of 6 minus 20 divided by 4. When I take a look at this, I'm going to say I need to work from this parentheses and organize that first. And I'm going to have to divide before I do that subtraction. So taking a look at this, I'm going to have 19 minus 3 times the quantity of 6 minus 5. Because 20 divided by 4 is 5. From here I need to simplify the parentheses, and I will get 19 minus 3 times 1. And 19 minus 3 times 1 is the same thing as 19 times minus 3. And 19 minus 3 gives me a positive 16. Alright, let's take a look at 2 more examples, and you will have a couple on your way. So our next page has extra examples, and these are examples that we're working with absolute value also, since absolute value is a type of grouping symbol. So here we're going to start with, this is our 7th example. And with absolute value it says 15 divided by 5 plus the absolute value of the quantity of 10 minus 12. So first I'm going to take 15 divided by 5 plus the absolute value of 10 minus 12, and since that's the grouping symbol, that needs to be simplified first. 10 minus 12 is the same thing as negative 2, and the absolute value of negative 2 is the same thing as positive 2. So I'm going to just plug in a positive 2 and simplify. So 15 divided by 5 plus 2, since the absolute value is always a positive result with whatever is inside. Now I'm going to take 15 divided by 5 and get 3, and 3 plus 2 is going to give me a positive 5. Our last example to do together is this one down here. And let me put that in, we're going to write an 8. And the example with an absolute value, another one, we have negative 2 plus the absolute value of the quantity of 1 minus 4, raised to the power of 3, all divided by 25. So multiple steps happening here. Again, our numerator, we need to remember, has brackets around it. It is an invisible grouping symbol as well. But we want to work from the inside out when we have multiple grouping symbols. So we're going to take 1 minus 4 and start there and end up with the absolute value of negative 3. So I'm going to write down negative 2 plus the absolute value of negative 3 raised to the power of 3, all divided by 25. Since the absolute value of 3 is the same thing as positive 3, I'm going to raise that to a power of 3, as I did over here, and find that 3 times 3 times 3 is the same thing as positive 27. So plugging in a positive 27 to this piece of the equation, I'll end up with negative 2 plus 27 divided by 25. Still working on simplifying the numerator, I have negative 2 plus 27, which gives me 25 over 25, which can be reduced down to a positive 1. Now there's 3 for you to try on your own. Please attempt these as you get full credit for any type of attempt that you show on these, and we'll go over them in class. Thanks so much for your time.